Hi everyone, so this video is going to be a quick tutorial on how to get the MSU firmware setup. Basically the Marlin branch of the MSU setup. So for the people that don't know, the MSU is basically a really cheap, so like around 50 USD, way to get multi-material and multi-color 3D printing on most FDM 3D printers. And yeah, this is just going to be going over the firmware setup. Hopefully this can be useful to some people that were stuck at this level. And yeah. Hopefully some of you guys can enjoy this, even though it's quite a long one. But yeah, let's get right into it. Alright, so we are here on a brand new virtual machine, and today's video is basically going to be a quick and short tutorial on how to get the MSU set up. So as you can see, I'm on a brand new install of Windows, so in a virtual machine. And this will ensure that, let's say, I don't skip any steps and I have the pretty much same experience as what you will have. So the first thing I'm going to do is install Chrome. Because Edge should just not exist. All right. So Chrome. And yeah, my bad if I sound or look weird. I'm pretty sick right now, so that explains it. Alright, so now that I have Chrome installed, there are a couple GitHub repositories that you will need access to. So the first thing to do is, if you don't have a GitHub account, you should probably create one. So what I'm going to do now is go through the sign up process, but if you already have a GitHub account, you don't have to do that. All right, and now we should have a GitHub account. I'm not going to personalize this account because honestly, it does not really matter. And my account has been flagged. This is of course because I'm using a temporary email and not, I don't look like a normal user. I'm gonna use dark mode, and just so that I can save my eyes. Perfect. And now we'll bookmark, or at least let's say have quick access to a couple repositories that you might need. So the first one is simply the MSU repository. So the material switching unit. So this first repository is where you're gonna have essentially all the parts, and you also have links to the Marlin repository and to Clipper MSU. So if you click on that link on Marlin, it's going to take you to my own fork of Marlin. What a fork is, in very short, is there's the official Marlin release in GitHub and codebase. I'm creating a parallel copy of that I can work on and that I own and basically can manage. And once I'm done with my code changes, if I wanted to contribute to the original project, I could, let's say, merge stuff from my fork to the original fork. And this is something you're gonna be doing, well, not the contributing part, but forking, because it allows you to do pretty cool stuff. And here, select the branch 2.1.2 -MSU. Because yeah, it's the branch that we're going to be working with here, and it's essentially pinned to the 2.1.2 version of Marlin. And here, if you can see, it says fork from Marlin firmware Marlin. So if we click on that, so let me bookmark this. So this is the MSU. This is my fork of Marlin, and this is the original branch of Marlin. What we actually want here is the configs for Marlin. So this is essentially all this stuff, basically pre-built configurations that we can use for Marlin. And here what interests us is the release 2.1.2, which is basically what the MSU is based on. Right now we're pinned to. And in there, what you can find is example configurations for different printers. And in my case, I'm interested in the Elegoo Neptune 2, but if you have any other printer, as you can see, there are quite a lot of examples. So let's go to Elegoo Neptune 2, and in here you basically have a couple of files and configuration examples, but we'll come back to that later. Now, there are a couple things you're going to need in terms of software. So the first thing is VS Code. This is basically a code editor that will allow us to edit our Marlin fork and just configure everything. The next thing we will need is Git, not GitHub, Git. I will have all of that linked down below as well. So Git, download Git, 64 bit. And the last thing you will need is GitHub Desktop. So this is not 100% necessary because essentially anything you do in GitHub Desktop is basically Git commands, but it gives you a nice GUI, so user interface that you can work with. And this is what I'm going to use for this tutorial because it's easier for, let's say, beginners. But yeah, if you happen to be on a platform that doesn't support GitHub Desktop, or you don't want to just GitHub Desktop, you can of course use the corresponding Git commands. So let's go through the setup of all those different things. Usually most of the defaults are correct. You might want to look into them, but for my purpose, this is what I'm going to stick with. Just all the defaults. And here on GitHub Desktop, it's going to ask you to sign in. So that's what you're going to do. And I'm going to authorize. And what this basically does is link your GitHub Desktop app to your actual GitHub account that you either just created or already have. And now we have GitHub Desktop, which will allow us to clone repositories and do different Git actions through a GUI, which will make things probably easier for quite a few people. Now let's go through all the defaults once again. GitHub, VS Code is done downloading. And we have Git installed as well. So that's pretty much it for the software installation side of things. Afterwards, what we're gonna do is actually start working on basically getting your own fork of Marlin locally, and start using VS Code. Okay, so now that you have what you need installed, you're gonna go back to not the MSU repo, but yes. So you're gonna go back to the my Marlin fork, and make sure that you're on the 2.1.2. Actually, it's not that important, but we're using the 2.1.2 MSU branch, and you're gonna click this little fork button, and essentially what this is gonna create is remove the bug fix branch only, because we want all of them. And here you can give it a custom name, but I will call it Marlin, and here you can create fork. So what this is going to do is, in the same way that I created a copy of the Marlin repo in my things, here you're creating a copy of my copy, which means that the changes you do, you can contribute them to my repository, but you can also contribute them up to Marlin if you ever have the need to do so. But it's a bit outside the scope of this tutorial. So now that you have created your own fork, basically what's going to happen is that on your profile, you now have your own fork. And this is kind of like a folder you share with everyone. So just it shouldn't have anything confidential in there, but know that any modifications you do to this branch and this repository are public. If you happen, I don't think you can make a fork private. But this is just something to note. If you happen to not want to use GitHub or not use your own fork, which brings a lot of benefits, but I can understand why someone would not want to do that. What you can do is if you go back to this branch, you can do code download zip, and what it's going to do is essentially just get you all the files. But this is not what I'm going to follow through this repository. Essentially, it's an option you have if you want just to code locally and no backup, no GitHub, no nothing, which is a possibility, but we're not going to go over it. So essentially, now that you have your branch, so your own branch, what you're going to do is that you're going to clone it from on your local computer. So you're going to click clone a repository from the internet, and here, refresh this list. What should appear here is either a single repository if you only have one, but you might have others, and you're going to want to clone this fork of Marlin, and your local path would be where the physical files, so physical other files will be stored. So just select somewhere that you will remember. In this case, I'm going to put it on the desktop. So what this is basically doing is downloading the files in the same way that downloaded them there, but it's in the repo. So what you can see and do is upload, well, basically push code changes online, and have revision history and all that kind of stuff. But yeah, once again, if you don't want to do that, you can just download the zip file like I showed before, and you will have the code here, which is exactly what we just downloaded. So it's exactly what we have here. So here you have to contribute to the project or for my own purposes. In this case, it's more than likely going to be for my own purposes, but this doesn't change too much. And in terms of branch, be careful that you select the 1.2, so 2.1.2, 2.1.2 MSU branch. What this branch is essentially the Marlin modified code for the MSU, but pinned to the 2.1.2 release. That way you can just grab the examples from the repo where all the configs are. So if you're here, what this basically means is that now on our computer, we have a copy of the 2.1.2 MSU branch, which you can work with. So what you're going to want to do now is open this using VS Code, which you just downloaded. So you can think of that just like a notepad or I don't know, Word on steroids to work on code. So you can choose your theme, but what you're going to do is file, open folder, desktop, or wherever you put your Marlin repo, and select folder. And now it's going to open this repository. Yes, I trust the authors. And right now you have access to all the different files and all the different configurations. So now it's going to probably prompt you, do you want to download the recommended extensions for this repository? For the purpose of this demo, I'm going to say no and download them manually. But if you click install, what it will get you is Platform.io and I think another extension. But let's say that the one we really need is Platform.io IDE. And if I click install right there, it's going to download Platform.io, which is what's going to allow you to upload your firmware to your boards and just handle all of that. So once it's installed, it will probably prompt you to restart VS Code. So I'm going to wait a bit for the download to continue. Okay, and now it prompts you, please reload the window. So that's what we're going to do. Okay, so now they have Platform.io pretty much installed. If you click on there, you will see you have a list of all the different boards that are available to you. So in this case, what you're going to want is to know which board your printer is running. So this is something that the Marlin config can help you with. So what we're going to have on the left is the code. And on the right, we're going to have the example configurations here. So once again, if you go to Marlin Firmware /configurations, link is going to be down below. And you select the branch, very, very important, because configuration files are not forwards or backwards compatible, at least to my knowledge. And once you're there, if you select config, examples, you have access to a lot of different folders which contain configuration for your specific printer. So in my case, I have the Elegoo Neptune 2, which is what I'm going to be configuring today. And if you look here in the README, it will probably give you information about how to do your specific setup, or if there is anything that you need to be aware of. So in this case, I think I have the 1.3, or I might even have the 1.4. I'm not quite sure. But essentially what you're going to want to do is in platform.io.ini, in default envs, you're going to either select default envs and replace that with whatever you're planning on using. I think in my case, it's actually maybe the 1.2. So that's stuff you have to figure it out. So quick Google search or looking at your specific board might help you out to find that thing. And if you really have trouble, you can message me on Discord. But yeah, so once you have that selected, or the second option is to find which board you have in the project task. So MKS, Robin, Nano, V1.2 is basically what I have, I think. So yeah, or either find it in the project task if it's available. But yeah, for now, we'll come back to this. So now you have two files, so configuration advanced.h and configuration.h. Those two files are made basically to set up your printer. And if you can notice here in the config example, you have access to those two files. So what you're going to do is select that configuration file, copy it, select the entire configuration.h file, Control V, which will essentially basically copy paste the example configuration file in here. And if you do Control, I'm going to enable autosave, but here Control S will save the file, same thing here. But what I would rather have is autosave enable. So if you didn't see what I did, File, Preferences, Settings, autosave, put after delay. Another setting which is nice is here, if I open File, it will not open new tabs. So if you want to open new tabs every time, which is what I prefer, once again, you can do preview. So Workbench Editor enable preview, disable that, and that will mean that every time you click a file, it will open it and it will stay here, even if you don't edit it or anything. So now we just copy pasted this entire thing in here. Now the only problem, and if you open GitHub Desktop, you will be able to see that. So here you can see the different changes you made. The .vscode/extension file is something that VS Code generates. You don't really have to care about that. If you see it, so platform.io.ini, this was a change we just did. So to specify the board. The next thing is the configuration.h. So here, what you can see is that it adds configuration specifically for your board, defines your board, the serial ports, the baud rate, all that kind of stuff that you would have to configure manually. But here, what it does, it also removes the custom code to configure the MSU, because once again, the MSU is not yet part of the official Marlin release, meaning that the example configuration files don't have the MSU configuration options. So what you're going to want to do is copy, paste all that stuff that you removed, so Control C, and then put it back to where it was, so at line 263, or actually right after MMU. So if you look for the MMU2 here, define MMU model %MMU2, you can put it anywhere in the config file, but for the sake of keeping it in the same place, you probably should put it right after the MMU2 config. It also makes quite a bit of sense. And as you can see, the thing in red, which shows deletions, just is no longer there, meaning that we only have the configs that we want. So the next thing we have to do is the configurations advanced. So advanced configurations files. So if you click here, that will copy it. In this case, there's no custom MSU stuff in there, so you can just Control A, Control V. So select all and replace it with this file. And as you will see here, it also configures everything for the Neptune 2 or whichever board you picked. So this is where the first real test is going to happen. So with that default configurations, before going too deep into modifying it or anything, you're going to try building it. So if you press Control Shift B, you can do platform.io.build, or since I opened previously the Nano board, you can also select that. But in this case, I'm going to select platform.io.build, and here I get an error. So this is due actually because unknown environment name, which is what I configured here in the Marlin config example, and that's actually an error that I've already encountered, which just seems to be inconsistency in there. And the actually valid name, if you look for MKS Robin Nano in here, so this is some stuff that you might encounter, and basically Googling stuff and looking online is probably what's going to help you out. And if you look through all of those, you will see that one of them here is named V1, V2 USB mode. The right board, I'm going to press Ctrl-Shift-B again, platform.io.build, and here, what is going on? So, okay, I just had to click it again. So, Ctrl-Shift-Build. And here what it does is that it grabs specific stuff for your board and then compiles all of the C++ files and everything in the Marlin configuration. And the output of that is a binary file, which can then put onto an SD card and insert that SD card into your board and then flash it. So if you see yellow messages, those are usually just warnings, so nothing too crazy to worry about. What's really problematic is when you have red stuff, but here you can see that the build was successful and that everything looks good. So if I go inside of .pio, which is the .platform.io folder, into builds, then the specific board that I have, you're going to see that binary file. So in this case, it's named illigu.bin. That's simply because the Neptune 2 requires a binary file named this way, but what it will more than likely be named is firmware.bin. So what you can now do is copy that binary file and put it onto an SD card, insert that SD card into your printer, reboot your printer, wait a couple seconds/minutes, and afterwards you will test if your configuration is working in, let's say, single material mode. So once that's done and you've confirmed that it's working, what you can do is do your specific configuration for the MSU. So this is where you go into your configuration file. Let's say that if you don't see this, you can search for MSU. Actually, I'm going to show you a GitHub feature before that. So what's really nice with GitHub is that you have version control. It's also a great tool to contribute and collaborate on code. And basically it's commit based. So imagine a commit as a save point for your code. So in this case, we confirm that it works and that it's, let's say, saved. So what we're going to do is, so you have two options. If you have a single printer and don't really care about your setup, you can just commit it here. What I would recommend is that you click on this 2.1 to MSU and click new branch. And then create branch based on 2.1.2-MSU. This branch is basically like a fork, but locally. So this creates a copy of the code of 2.1.2-MSU. Be very careful to select that. And what this allows you to do is to have a lot of different branches for each printer you have, because you might want to do that configuration multiple times. So let's say this one is going to be named so Neptune 2 MSU. And so you want to name that to the name of your printer or something that will make you remember which printer it's for and which board it's for. So I'm going to create this branch. And what you're going to click is bring my changes to Neptune 2 MSU. So what this creates is a new branch. So as you can see, you have the list of all the different branches. This is the one that you copied originally, and this is a copy of that one, and then Neptune 2 MSU, to which you can add your own changes. And what you're going to do now is commit those changes, so essentially creating a save point for your code. And yeah, you just need to name that commit. So here I'm going to name it basic, so single material configuration for illigu Neptune 2. This might be a bit long of a commit, but yeah, it doesn't really matter for this purpose since this is pretty local. No one else is going to look at this. So you are going to select the files that you want to commit. Once again, this .vs Code extension stuff isn't necessary. This is not actually part of the code base. So configuration.h, configuration advanced.h, and platform.ini. Just check that all those code changes make sense. So you can look at, so green stuff has been added, red stuff was been removed or deleted. And here that looks good. So what I'm going to do is commit to Neptune 2, and then I'm going to click publish branch. So what this basically does is that it pushes it online to your own repository. So if I go back on Chrome right now and go on GitHub, so what you will see is that in your repositories and on your profile, now there will be a Marlin that's for my original Marlin branch. And in there, so you have the original, so you have the 2.1.2 MSU, which is what you were working on. And then there is the Neptune 2 with MSU, which is a branch we just created. So if you copy that branch, oh, hold on. Actually, it might not be the name. Neptune 2 MSU. Not with. This is actually one of my old ones. I will delete it so that we don't have this problem for you guys. But yeah, Neptune 2. Hold on. Why do I not see it? Oh, maybe view all branches. Yeah, all right. If you go and view all branches, you will be able to see this one. I think that this is mostly because it's only showing my branches and other ones that you created. In any case, you can see that that branch is there and that the commit that we just did is here. And that is basically going to add a little bit of code save on top of my changes. And if you click on there, you're going to have a breakdown of all your code changes. So now that we have our basic config, that you have it running, that you tested it with single nozzle mode, that it prints decently, what we're going to want to do now is actually configure the MSU. So let me pull up. So what you're going to want to do is just give me a second. I want to get the right value, so I'm looking at my already made code changes. So if you go in here and you see that define MSU, if you uncomment that, that will enable the MSU code and actually make the MSU functional. So here you're going to select one of those three. So in this case, it's the bone setup. So you can uncomment that to define it. Then there's the LCD menu. So I don't see any reason why someone would comment that out, but you can if you want to. Afterwards, you have all those parameters. So those are essentially allow you to change your configuration. So your idler servo numbers, if you have multiple servos on your printer, let's say for, I don't know, auto bed leveling sensor or something of the sort, you can select the one that you want to use for the MSU. In my case, it's going to be 0 because I only have one servo, which is the MSU one. Then you're going to have your servo offset. So this is essentially a positive addition to your servo rotation, which allows you to adjust your, basically, it allows you to offset the servo position so that if, depending on how you like screwed it in and mounted it, you might need to offset it basically. Then the bearing angle, you probably don't have to change that. That's essentially the number of degrees of rotation between each bearing. It might be useful if you have a different idler or if you're happy to modify physical parts. The loading and unloading speed, 25 is a fair value. You can change that if you want it to go faster or slower. And then there is the parking position, which is the angle at which the servo will go when you click home. So let's say, depending on how you built it or whatever you did, you might decide that you either want the park in the very front or the very back or some value in between, which is something you can adjust. Then if you're still in a Ubuntu setup, those two settings aren't necessary for you. Otherwise, it's basically just defining steps per millimeter, certain extrusion number. The next value you're going to want is the MSU Ubuntu length. So essentially, some of the retraction. So after your tool change, some of the retraction is going to be handled by the MSU, and some of the retraction is going to be handled by the slicer. The first half of the retraction is handled by your firmware, while the later half is your slicer, let's say. So the MSU gear length would be, this is only necessary for direct drive setups, and this is basically the amount of retraction until it clears the gear. And yeah, your bottom tube length is just how much you want to retract before passing it on to the slicer. That doesn't need to be super, super high. But yeah, basically just clearing it enough out of the nozzle so that like you don't have any problems. And then you can use the slicer settings to retract it to the proper position afterwards. All right, so as I'm editing this, I realized that I've forgotten to mention that, so first thing, I am sick again. Don't ask why. This when I edit those videos, even though it's a couple months later. As I'm editing this, I realized that I've forgotten to mention that the access steps per unit needs to be edited from your default config more than likely. So this simply includes the MSU at least in a Bowden setup. So in a Bowden setup, you want to change that default access steps per unit from whatever value you had before to 150 or around that. So in any case, when you configure your own Marlin, you probably want to do an extruder like a calibration, which you can find online on YouTube, how to do that. But yes, your ballpark number that I have that should work decently is 150, which might be a bit higher than what is on like your regular printer. So for the Neptune 2, for example, it was 95 in the default configuration example, whereas the actual number I'm using right now is 150. If, however, you're using the direct drive setup, you will also have the extra setting here to have the steps per millimeter for the MSU. Actually, that probably shouldn't be 120 by default, but probably close to 150 or whatever you end up having to use for the actual MSU extruder. And then you'll still have your default machine steps per the millimeter that should still be good. Actually, steps per unit, because I guess now they have added millimeters or degrees. And yeah, essentially that's pretty much it. So now what we just did is that we copied the default configuration file. However, depending on your setup, you might have to change some values. So this is outside the scope of this video, but I just want to remind you that you're configuring your own firmware, meaning that you have a lot of choices. If you want to add like auto bed leveling, you can choose like different stuff about bed leveling. Let's say you can choose how many probe points, how fast it goes, all kinds of different things when you're advanced. So there are a lot of settings to play around with, and like this opens you up to configuring your own firmware, which has a lot of great benefits. So yeah, I just wanted to mention that just so that you don't think this is like just keep the default setup and go on with your life. If you want to customize it to your liking, definitely do so. So this would be like in the configuration.h and also in the configuration.advanced file, which also has a couple settings that are interesting to play with beyond just the default Marlin or like community provided setups for your device. So now that we have all those, let's say now that we have the MSU configured, we can rebuild it. So platform IO build. And if no bug snuck in while I was doing some code changes, it should succeed. And now you will have basically the MSU configured and some beautiful error messages. Move servo is undefined. Let me get back to you. Okay, so I actually found, so this error was due to my code changes. So this is kind of me doing a tutorial and testing it as well. But essentially, I have some servo stuff that's been deprecated in the new version, which I just updated to. So old code just didn't work anymore. More specifically, that move servo just does not exist anymore. So this is a good way to show what you should do if, let's say, there's an update, or if I push new code to the repository and you want to update your firmware. So what GitHub is really nice for is that you can do that without having to redo your entire configuration, copy pasting everything all over the place. So the only thing you have to do is, so be in your branch, make sure that everything is either committed and that you don't have change files. So in this case, I'm gonna commit this and name it basic MSU configuration. And I'm gonna discard this change, which is pretty much just nothing. And I can actually push the words in it. This would make it also updated in the cloud on GitHub. So if you want to update this simply with a new code change that I do, what you would do is go here to rebase current branch, and here you would search for so 2.1.2, and you want to make sure to take upstream 2.1.2. So here it's saying that this branch is up to date with Neptune 2 MSU. So this is probably because I need to fetch upstream. So fetching upstream ensures that we get everything from the new code changes. So and if now I do 2.1.2 and I do upstream here, this will update basically. So what this is gonna do is take your code changes and put them on top of my new updated code. So if I click rebase now, you will have to force push in order to publish it. That's simply because you change your GitHub history. If you change your history, like if you change in the way the file, like if you change anything time related, so in this case, what it does is it applies your commits that you did before those changes were there on top of the, basically on top of my new code. So if you're out of time, you have to force push because it's not let's say continuous path. Force push, if you're working by yourself, nothing to be worried about. This will just basically like force whatever is on your repo to be what's online. Now you have to be very careful that what you have locally is exactly what you want to have online, because what it will do is basically delete anything you had before. And if you're working with other people on GitHub, and let's say do not force push, usually it's a bad idea, and make sure that everyone is aware that you're going to force push if you need to do so. But this is going to be a bit too much to the depths of Git and version control. It's just that since I'm showing force push, I don't want anyone to do bad stuff, let's say. But yeah, so now basically, if you click on history, you can see that I have my two code changes that I did before on top of, and you can see what I was saying in terms of time being changed. So these two bug fixes were done 5 and 11 minutes ago, and our configuration was just done 30 minutes ago, and it puts it on top of it. So this is the kind of time change thing, which forces us to force push. And essentially this implements the two bug fixes that I just did. So this is kind of the process if you wanted to update your repo. And now that we have fixed this, you will see that the servo thing is now changed. And if I hit build, it should now build. And once that's done, we basically have compiled Marlin for, yeah, we have Marlin compiled for a specific printer, and yeah, it's ready to be flashed. So right now what you can do is take your file, platform.io file, build your specific printer, this liquid.bin file, put it on an SD card, insert it into your printer, reset your printer, and you'll have the new firmware with the MSU, which should hopefully work. So now we're going to go into a bit more advanced stuff. So while playing around with the board. So you might have, so if your board doesn't support a servo, or if anything, if you have a very specific board that you need to configure stuff for, Marlin actually has so specific. So if you go into source pins, source pins, then you're going to try to find your specific board. So in my case, I know that it's an MSU32F1 and the SKR, the MKS Robin Nano. And you can see here that we have basically a lot of config files. So once again, this is more advanced stuff. If you don't have anything crazy or too specific, you shouldn't have to do that. So you can just skip ahead to the next part of the video, which is actually going to be showing, once you flash, what the printer looks like. So here, basically you can have multiple, like you have common v1.1, and common is essentially going to be like where most of the stuff usually is, and then very specific things are going to be into the specific version stuff. And in my case, I'm using a different extruder port. So if you go here, basically here, what you can do is define your servo pin if you need to. So servo 0 pin is PHP in my case. But if, let's say, you're using an Ender 3 board and you wire up a servo to it, it will more than likely not have a servo 0 pin defined. So you would have to go into your boards. So it's probably, I don't remember the name of the board, but you would have to figure that out. You go in there and you could add a servo 0 pin, and then you would have to figure which pin you connected your servo to. And let me look at this. So this, so we'd have to Google it essentially, but this is a pinout of the, let's say, Ender 3 board. I don't know which version it is, but if you happen to connect the servo and it doesn't have it, you can go in there and look. I don't know, if you don't use, let's say, the Y plus end stop, you could actually connect your servo to that. And then in your pins file, you connect your servo plus and minus port to 5 volts or another source of DC current. And then let's say I use so D15, so you would go there, and if you had to add a servo, so it would be servo 0. In my case, I'm going to say this is servo 1. And then for the pins file, you would define, hold on. Oh, I'm dealing with local and virtual machine at the same time, which isn't great. But yeah, let's say, so D15, you just do this D15, and that would allow you to define a servo on a board that doesn't necessarily have it. In my case, the changes that I did is I busted the extruder port. So E1, it should be MKS Robin. Oh, it's the Robin E3. I have the Robin Nano. So the Robin Nano. So in my case, I have the extruder 1 and extruder 0 basically flipped because I just broke the E0 pin. So what I'm gonna do is just quickly swap them out. 1, 1. And you shouldn't have to do that. You really shouldn't have to do that. Only do that if you know specifically what you're doing and if you've had problems or something of the sort. And another thing you can do is so disable inactive. So inactive. Oh, it's not in there. Oh, that's just a confusion notes file. So those are the changes that I made. But yeah. Once again, this is kind of outside the scope of what I wanted to show you. This is just needed for my board to work. So we can build it again. And once it's built, I'm actually going to flash it onto my board. All right, so I'm actually going to show you the actual flashing process for the board. So I'm gonna just Control-Shift-B, then platform.io.build. Once that is built, what I will basically do is, so instead of actually flashing the printer itself, well, I'm going to flash the printer, but instead of having to deal with like a little SD card and everything, what I'm going to use is an Octoprint extension, but consider this as being exactly like just like taking your SD card and actually flashing your board. So I'm gonna turn on the printer so that it can, what it basically does is that, so you have your SD card here, it kind of like, it just transfers your binary file onto your SD card and then resets your printer. So this printer is on, it already has the exact same firmware, but that does not really matter. The goal is simply to show that it works. So here what we have is we connect to the printer. Alright, connect. And then I use this little Octoprint firmware updater plugin to browse the file. So let me get that. So desktop, material switching unit. Okay, so here we're gonna go into hold on, can you focus? Into marlin.pio.build, mks-robin-nano, iligu.bin. Once that's selected, what I'm just going to do is click flash from file. Now it's flashing, it's basically doing the transfer, and then it's sending the firmware to printer, and then it's going to say resetting the printer. And what I'm actually going to show you is it's updating. So it's here, and it should soon reset the printer, and we'll see it flash with the new firmware. So hold on a second. It can take quite a while to transfer like a couple megabytes onto that really slow SD card. I don't know if you can see it now, but as you can see, it's booting and it's updating. So like the experience might be a bit different based on like what printer you have, but it's more than likely gonna be pretty similar. And yeah, sorry for the mess. I'm like printing quite a lot of stuff right now. So once that's updated, it'll probably ask me to reconfigure the screen, and it's a bit of a pain. I don't know why right now it needs it to be like good on the first shot, otherwise it crashes. So I'm going to use that to be very precise. This is going to be different on your printer. You might not have a touch screen, but like the UI is like pretty similar. So now that you have flashed it, how do you check that this works properly with the MSU? The single difference with your regular printer is going to be that you now have an like basically extra servo controlling that MSU. So what you will do is you will go into your menu, and it's going to be a similar menu. Probably like with your knob you're going to have like a similar options, but the interesting menu that's going to appear is the MSU menu. You have a couple of options. Park idler, this would be like a home option. You're going to have choose filament, which is going to be like your actual tool change, and then you're going to have set idler position. The first thing that I like to try is set idler position, and then you can work your way around through all the 5 positions. So let's say I do 1, and you might have heard it moved to position 1, and what you want to check is that the like bearing that's being pressed is against this filament here, and that is pretty well aligned. If it's not, you want to adjust the settings in the config file, but by default I think it should be correct. And right here, one thing you could do is if it's misaligned, you basically want to undo your link to your servo, align it to be with the one, and then retighten everything. So basically, because you have to do your first alignment, and then you can like play with software to offset it. But basically, you want to check that one aligns, and then I'm gonna walk through on the settings. So set idler position 2, 3, 4, and 5. And once we know that all of that is good, what we can actually do is choose filament, and that will actually basically just send a T0 to T1 command. So if I do filament 1, what it does now is it retracts the filament a little bit, then it selects the new filament and pushes it back in. And yeah, now you have a printer that has MSU Firmware on it. and that's fully functional and ready to print. Well, ready to print. You just have like the slicer configs. It might be this video, it might not be. We'll see what I do.